So you guys loved the old camera angles, and I've tried really hard now to make a new camera angle that is similar to how I used to do it, but in both landscape and portrait. In this video, we're going to take a look at another Neo Geo AES. This is a local customer that wants to have the clean power and the clean RGB upgrades to get the best visual out of the console. So let's just take a look. Now the Neo Geo already outputs RGB, so I've gone ahead and connected up a clean RGB SCART cable. But one of the other concerns is, these models, you can have a 9-volt inverted, you can accidentally plug in a 9-volt non-inverted, and these models can also be 5-volt, and if you plug in a 9-volt like this, you can blow the whole system up. So often customers opt for replacing this for a USB-C port that we do called the clean power. To check inside of here, just take this game out and lift up. You'll see in here, we've got this giant coil and this chip here, so this is how you identify a 9-volt version. The problem is you have to open it up to do that, and it's very easy to accidentally plug in the wrong connector at the back here and kill the console. Let's just take a look at what the stock RGB looks like when we turn the console on. So now going through an OSSC, we can see here now we have a nice clean RGB output. It's not perfect, so we have a slight offset in colour, but this model is not far off at all. But the difference is in perfection. So some people want a perfect output, and that's what the customer's opted for. So you'll see from here, depending on what input device you use, CRTs are normally quite forgiving. This HDMI capture is pretty clean thanks to it being an OSSC, but the colours aren't quite perfect. The likelihood is though, unless you're really keen on RGB, this output will do most people. It's also a good time to test the console by just simply playing a bit of Metal Slug. The Neo Geo, this is an older model that's more compact versus the large one. I quite like playing with these now, as opposed to larger analog sticks, and they've got a little dimple here for playing with your thumb like this. So enough testing for now. Let's just crack this open and do the work that we need to do. So inside, if we just lift the lid off, I've taken the screws off already, we can see we have the board here. We can see we've already had some work done here with this bodge wire going through here, so we know this has already got some work, but we haven't seen any faults. The customer's mentioned it seems fine as well, so we don't really need to investigate any failures as such. We do need to swap this port out for USB-C, and we need to correct these resistors here. So see this bank where it says 6.8K, 3K, 6.8K, 3K. If we just go over to retro6.wiki, and if we go down to Neo Geo AES, and we can see voltage levels will be in RGB voltage levels. This will give you all the guides you need to know of how to correct the circuit, how to check the circuit, and where the mod is to be done, as well as if you want to use an oscilloscope to fully correct this and see, you can. And then here's a more visual of before and after. So you can see this white is quite grey, and then after it goes bright white. And again here, dull, bright, dull, bright. Now in our version, it's not that drastic because it's actually closer to correct, but this is what we do. We correct the voltage level using an oscilloscope, and I've made a table up the top here, so it's nice and quick to find out what we need to do. This resistance here is referring to the 6.8K resistors, and we need to change them. We need to change them based on the model number. So the model number here is a 3-6. So in here, the 3-6, we need to drop them to 5.2. That's the mod we need to do. While we're here, if we check other cleanups as well, if we check jail bar fix, you can see the 3.6 needs a jail bar fix to prevent this. But considering we haven't seen that, I'm going to guess that work's also been done. And if we now remove this from the shell, let's just take a look. And we're looking up this area here, and we can see visually in this area, see these cuts. This will prevent the jail bars. So it's already had that work done. We will replace these resistors with the correct values. And then because most normal resistors are longer than the pads, as you see here, they're actually smaller, we'll poke this through and stick it up on its end basically. So it goes in like that, and then fold the wire down like this. Now for the USB mod, we don't really do a pre-made solution yet. What I do is get a Master System Clean Power, which comes with this bracket. Then I use a Dreamcast Clean Power bracket, so we can get a nice combination of the two. Bridge the fuse here, because this needs more power for the Neo Geo. And then every version varies. This one being the 3.6, we have to remove this DC port, cut the traces to both sides of the switch, remove the inductor, diode, and resistor, and then wire this up. All the instructions are on retro6.wiki, but until I make an actual mod for this, this is basically a retrofit using existing hardware that we've made. And on the 1.6 version, basically the regulator, which is here, is always receiving power, and the power switch simply tells it to enable or disable. So these two wires are just basically telling the chip to enable or disable. So with those wires on now, we'll just flip over, and then we just want to remove this inductor, this diode, and this resistor. And if you remove one side at a time on the diode, it's much easier. The inductor's got some hot glue keeping it in place, but you can either warm up straight from the top and just melt through the glue, or you can warm up from the underside. It all depends how you want to do it. I'm just going to warm up from the top side and lift the wire out. That's one side of the coil. And then the other side, you want to make sure you don't melt this button, because that's obviously the reset button, so be careful with your iron here. And you can get in here, or it's probably safer on this one to do it from the other side of the board. And that's out for me. We'll just clean up this glue. And the final component to remove is this 1K resistor, which you can do fairly easily by flooding both sides with solder. And then we'll take the resistor out as well and just clean up the area. And now for this connector, all we need to do is place the USB in position here so that it's nice and solid on here. And I just use some epoxy or Q-bond to hold all this in place. And that's now nicely solid in place and not going anywhere. We want to check this in the shell, that we have a good central fit. And you can see when installed in the shell, that's nice and central. And with the two wires now attached to the outputs, we're ready to build and test this. So we'll connect up our USB. You want to use a high quality USB plug so you don't get any video noise. And connect in, and let's turn on. And there it is, all working. So now we're running off USB-C power. You'll probably notice now the blues are much brighter, the colours are generally a lot closer to where we want them. And it should be nice, sharp and clean. And now we have the safety of a USB-C plug that you can't overvolt the system and accidentally damage this. These things do cost hundreds of pounds. You can easily get to over £1,000 with one game, controller and console. So you do really want to look after these. I do an LED button mod for this as well, so you can glow the button a different colour, but the customer hasn't gone for that one. But overall now this is all restored, ready to go, and we'll get it back to the customer.